Hi class. In this lecture here, I want to talk about the two types of hypothesis tests we did for means. Okay, so we had two sample tests for a mean. And we over the last two lectures, we looked at two different types. We had what we called tests for independent samples. And then we had paired samples. And so I just want to clear up, like, does it really matter which test you use? Like, would you get different results if you took the same data and ran them under the two different tests? And so it does. It really does matter, okay? And so you have to be careful. So what I want to do in this one example here is I want to show you that you're going to get different results depending on which test you run and why it's, you have to make sure you run the correct type of test. All right, so here's the problem. This is about using a gasoline additive. So suppose you want to test the effectiveness of a new gasoline additive. And basically what I mean by that is if it will increase the miles per gallon that a car gets, okay? And I always like to say, well, will I still be using this example in 10 years or will it only be electric cars by then? But anyways, so the gas mileage of miles per gallon of 10 randomly selected cars, both with and then without the new gas additive, are shown below, okay? So look, the first thing you got to ask yourself is like, are these independent samples or are they paired? Well, so look, you have 10 cars. So this is car 1, car 2, 3, 4, car 5, 6, 7, 8, 9, and 10. And so you have 10 cars, but you have two values, assigned to each of those cars. So you basically have a before, so without the additive, and then you have an after when you use the additive. And so, right off the bat, you can see this is a paired, okay? So like if you want to test to see if this is indeed if adding the additive does indeed increase the miles per gallon on average, you should run this as a paired sample test, okay? But let's just see what happens if you do it both ways and see if you make different conclusions. All right, so here's what I want to do. I want to apply the paired t-test to decide at the 0.05 level of significance whether the gasoline additive is effective at increasing the miles per gallon, and this is on average. And then I want to apply the non-pooled t-test to the sample data to perform the hypothesis test and make a conclusion, and then see if you make different conclusions, and then talk about why performing the test the way we did in part B here is inappropriate. Okay, so let's take this data here and run it through the 5 steps of the hypothesis test and see what conclusion we make. So let's indeed see if the additive does improve miles per gallon on average. So you have to go through the 5 steps, right? So step 1. Okay, so this is as a paired test. So we're going to let mu sub 1 be equal to, looking back, we'll have it with the additive, okay? So mean miles per gallon with additive. And then mu sub 2 will be equal to mean miles per gallon without the additive. And then we'll define, because it's paired, we're going to define the difference as mu1 minus mu2. So my hypothesis test should look like this. I'm investigating something involving the difference. And so if I want to see if the additive is indeed effective, we'll start with the assumption that the mean difference is 0. And then as it's mu1 minus mu2, if there is indeed an impact, this should be greater than 0. We should be seeing a massive increase, or at least an increase greater than 0 on average with the difference. Okay. Step 2. Alpha is equal to 0.05. Now step 3 and 4. Step 3 is the test statistic. And step 4 is the p-value. And we're going to use the calculator for this. Okay? So I'm going to go back and load up your trusty calculator here. And so what we're going to do is I'm going to input the two into my list, right? So in L1, it's going to be the width additive. The miles per gallon is getting with that additive in it. This one car's only getting 13.7 even with the additive. Time to trade that in, I think. Ooh, 12.5. This one's even worse. Probably like a Hummer or something like that. 8.1. Oof. It's an old time car. And then in L2, what we're going to do is we're going to put the without the additive. Okay, how many miles per gallon these cars are getting, without that additive that's claiming it increases Okay. And so remember when you're doing the paired, you're going to scroll over to L3 and you're going to calculate the difference, right? So it's going to be L1 minus L2. And you can see here the difference miles per gallon you're getting when you increase the additive. So then next, when you go back to the test, when you run paired test, remember from the last lecture here, you're going to just run a t-test. You're going to do the data. Start with the assumption there is no difference. Now the differences are in list 3 here. And then I'm going to go make this a right-tailed test. And then I'm going to scroll down to calculate. And you should see this. Okay, and I'll explain this in a second. So the test statistic here is 4.7143 when I round it. 7143, excuse me. And the p-value, now when you see this e to the minus 4 here, what that means is take this and move it to the left 4 spaces. So my p-value is actually 0.00055 when I round it. So it's a very low p-value, okay? So it is picking up a significant statistical probability that there is a difference. It's very statistically significant. So step 5 here, what we're saying is, our conclusion is we reject the null. This is because the p-value is less than the level of significance. And what here is evidence suggests that on average, using the additive improves miles per gallon. Okay, so on average, it looks like it does. And it is appropriate to use a paired test here, okay? You should use that paired test, right? Because the values are measured on the same car. All right, so now let's go back. So yes. Okay, yes. We are rejecting the null here. All right, so now let's apply so basically what next it's saying the non-pooled t-test. So I want to go back here. I want to use tests. And now I'm going to actually go to option number 4 here. Okay, option number 4 here. All right, so let's go back and redo the same basic setup here, okay? Step 1 was let's let and this is a non-pooled t-test. So again, mu sub 1 was equal to the mean miles per gallon with the additive, and mu sub 2 is equal to the mean miles per gallon without the additive. And here my test with the two sample t-test, I'll start with the assumption that mu1 is equal to mu2. And here what I want to test is, no way, that on average, the mean miles per gallon with the additive should be greater, should be much greater. So we'll run it at the same level of significance, that alpha is equal to 0.05. And so again, we're going to use our calculator. Step 3 is the test statistic. And step 4 here is the p-value. So look, now under the two sample t-test, under data, we got with the additive in L1, without the additive in L2, and our alternative here is that mu1 should be greater than mu2. Okay, right? That's what we're testing here. mu1 is greater than mu2. We're always, for our course, we're always going to do no pooled, and we're going to go to calculate. And you get wildly different results here. Look, here our test statistic is 0.1982. And our p-value here is 0.4225. So look at the difference. Look at the crazy difference in p-values here, okay? So here what we would do, if we had ran the test this way, we would fail to reject the null. Here, because the p-value is greater than alpha, and we would say that evidence suggests that on average, there is no difference in the means. In that mean miles per gallon. So we're like, oh, on average, it doesn't matter if you use the additive or without the additive. Okay. So you're going to make two different conclusions depending on the test you used, okay? So look, here we failed to reject. So look, you made two different conclusions. Yes, two different conclusions. So the question is like, why is performing the hypothesis test the way we did in part B, so that, you know, using that non-pooled t-test, that two sample t-test, inappropriate? Well, you got to actually think back to the lecture on that. One of the lectures we assumed was that they were independent samples. But these are not independent samples. The values that you get here, right, they're not independent of each other. Like, the value you're getting without the additive is going to impact what you're going to get with the additive on car number 1, right? Like, these are paired. They are not independent samples. So because they are not independent samples. So just, you know, sit down and think. Is there a before and after effect? Boom, it should be a paired test, right? That's what we're seeing here. Or do we really indeed have two independent samples, and then you can run it as a non-pooled t-test? All right, class, I hope this lecture did help show that, you know, selecting the test is incredibly important, and that if you don't select the right test, there is a chance you're going to get, you know, wildly different results or wildly inaccurate results.